We're going to continue the conversation about correlation coefficients and look a little bit more at the relationship between two variables and analyzing the correlation coefficient between them. The first set of problems here gives us 4 graphs, 4 scatter plots, and 4 combinations of variables, x and y variables. And our goal is to match up the xy variable with the graph that seems to represent that, and to see if those variables fit that graph well or not very well, and to explain our reasoning a little bit. So this would be a good point, if you're watching the video, just to pause the video and see if you can do a little matching yourself for the first 4 sets of variables there in the A, B, C, D graphs. So if you feel up for that, why don't you go ahead and pause right now. So if we're going to go through and look at the relationship, let's just start off by reading the first variables here. So the variables for number 1, the x variable on the x-axis says daily low temperature in Celsius for Denver, Colorado. And then the y variable, boxes of cereal in stock at a grocery store in Miami, Florida. So I guess you're asking yourself, are these two variables related to each other? Are they connected? Are they correlated is the word that we're using. Are they correlated? I hope your eyebrows are kind of raised right now because how would the daily temperature in Denver, Colorado be related to the boxes of cereal in stock at a grocery store in Miami? I know there's the whole butterfly effect and stuff, but those two variables don't seem to be related in any way, shape, or form, which means the correlation would be essentially 0, which means that the scatter plot would be very scattered. Okay, so let's see if which ones. I guess looking at the more scattered scatter plot, I think you're maybe honing into C and D. Now, at first, D kind of looks like it's more scattered, but D, you do have a bit of a relationship here. As one goes up, the other one seems to be going down. So I'm not sure that it's D. I think it's much more appropriate here to look at C right here, because this whole group of points here, there's no pattern to them, up or down. And so it makes sense that in this case, this would be like Denver temp and boxes of cereal as our two variables. All right. And maybe below we can just write a little bit about that. So in number 1, there would be no correlation between Denver temperature and Miami cereal. Those two variables are not related to each other in any way, shape, or form. So if we tried to graph the two, we would just get a scattered scatter plot with no trends. Okay. All right, let's look at the second one. So this one, average number of free throw shot in a season, basketball team score per game. All right, so free throws are a type of way of earning points in a basketball game. So it seems to make sense to me that as the number of free throws increases, then so would the score. But it's not the only way of scoring points in basketball. So you could get 3-pointers and 2-pointers and then also free throws. So it's not like one automatically affects the other, but it seems like there could be a positive correlation. Seems to me that's probably going to be maybe B here, in which we have one going up as the other one is also going up, but it's not like in perfect relationship. It's not perfectly correlated to each other. So number 2. As more free throws are shot, the score would be generally higher but not perfectly linear. correlated. Okay. Sorry if I wrote a little fast for you there. I'll be able to make both of them visible at the same time here. Okay. 3, measure student height in feet, measure student height in inches. Actually, I forgot to put the labels on the variables for the last one. So that was free throws versus score per game. Okay. So measured student height in feet, measured student height in inches. All right, so as the number of feet goes up for a student's height, so with the number of inches, and hopefully you are thinking now these have to be perfectly correlated because there's an exact number of inches in a foot. Every time you go up 1 foot in height, you're going to go up 12 inches. So this isn't really a scattered scatter plot. This is like, it's going to have to be linear. 1 foot is equal to 12 inches, always. All right, so this is a positive correlation, a strong positive correlation, and it's going to be perfectly linear. So that's going to have to be the first graph. So height in feet, height in inches. So this is number 3. For every 1 foot of height, the height in inches will increase by exactly 12 inches. So perfectly linear, strong correlation. Something like that. A little explanation there. Which then leaves us with our last one, which hopefully is D, average number of minutes spent in a waiting room, hospital satisfaction rating. Yeah, so it makes sense that as you wait more minutes, that your satisfaction rating is probably going to go down. And there's not a perfect relationship there. It's a pretty scattered scatter plot, but in general, it seems to be kind of sloping in a negative direction. So number 4, as you wait more minutes, satisfaction decreases. As one goes up, the other one goes down, but not perfectly correlated, not perfectly linear. So hopefully, in reasoning through that, it makes sense that those graphs are the most appropriate matches for the variables listed.